Hey everyone, in today's video we're taking a look at my personal Sansui AU-6600. I used this amp regularly in my previous setup, and one day I noticed there was some distortion out of one of the channels. And I was like, huh, that's weird. So I did a quick check and ran the preamplifier into a working power amplifier, and it sounded fine. So I know that there is something wrong in the power amplifier of this receiver. And that's kind of interesting because I actually restored this about 7 years ago. This is the first integrated amp I ever worked on. There's actually kind of a cool story behind it. But before I tell you the story, let's get a close-up look at this thing. So this is an integrated amplifier, and that means it has both a power amplifier and a preamplifier inside of it. What differentiates it from a receiver is that there is no tuner. So as you can see, it's all about the preamp and amp, I guess. The tone controls are kind of interesting. You've got like an on-off switch for them right here. Like you can defeat it or you can use these three knobs. You've got low and high filters. And then you've got little selectors for like what kind of bass and treble you want to see out of this. You've got an integrated volume balance knob. Then you've got a really nice tape monitor knob here. And then you've got your input selector. Then of course you've got a nice little attenuator for if you want to just kind of turn the volume down real quick. You just flip that switch, stereo mono, and then of course the loudness. So very simple, very elegant design. And the back of it's kind of interesting too, how the output transistors work. We'll see them later, but this is a heatsink right here. This is the heatsink for the output transistors. And then I always like when the inputs are kind of like this, because like if you're looking behind something, you can just kind of plug right in. So I do enjoy this. You've got a switch for whether you want your preamp and main amp connected or separated, which is what I had to use to test out the preamp on this thing. And what I find interesting about Sansui's is they have the positive speaker connections in the middle and the negatives on the outside, which I always thought was kind of interesting because, you know, the negative, that's just ground. It's the same connection on all four of these. So you've got your two, quote, hot connections, I guess, next to one another, whereas on another receiver or amplifier, they'd be on the outside. So I don't really know why they did that, but, you know, whatever. Sansui's always been a little bit different. But before we take it apart, we got to hook this thing up real quick and show you what I'm hearing, because I want you to understand what we're getting into here. Now, if you saw the Marantz 240 video, you know that this is a perfectly functioning preamplifier. Otherwise, there would have been a lot of distortion and nasty things happening when I was playing everyone's favorite song. So, you heard that. Now I'm going to play everyone's favorite song through this thing with the preamp. Take a listen. That's real wrong, real bad. So now let's go to the right channel, and that sounds great. So you see what we're dealing with here. That's not supposed to sound like that. So real quick, let's just turn this off and let's run it on the dim bulb. And let's watch this light bulb and see if we can see anything. I want to see if it gets brighter on the distorted channel or the working channel. So we're turned on here. We're set to the distorted channel. And it looks like there's really not that much being pulled through. So let's switch to the good channel. Okay, I had to turn it to max volume, but I just wanted to say that nothing happened on the dim bulbs. And then the last thing I'm curious about seeing is what does this waveform out of the distorted channel look like on the oscilloscope? So I'm going to connect that real quick, and we're just going to take a look and see what's happening. Okay, so I've got this thing hooked up to the scope. We've got the load resistors, and it's actually the left channel that is not working. So I'm going to show you what the right channel is doing. You know, we see it locks in and it clips like it should. I don't really care what voltage right now because, you know, that's not really what we're looking at. So, you know, right channel is great. But let's switch over to the left channel. I'm going to turn this up all the way and nothing is happening. But what we got to do is kind of decrease our volts per division. So we're kind of zooming in on what's going on here. And see, there we go. We've zoomed into the millivolts. So you can see I've got it turned up all the way. Let's go back to the right channel which is channel 2 right now, if I turn the volts per divisions all the way up to where channel 1 is, like, look at that. See? That's a lot. So, yeah, this is where we measure power, down at the, like 5-ish volts per division. So, let's look at this waveform. We see that we've got little spikes in it, which is, you know, bad. When it clips, it goes nuts, basically. That's a really nasty sound. That's kind of in line with what we've been hearing. So what I'm thinking is that it's maybe a smaller transistor in the power amplifier that's doing this, because normally if an output transistor is going bad, it's either not working or the amplifier is pulling a whole lot of current because, you know, the output transistors are working off of the big power supply. So let's see if we can make it not look like that anymore. Let's start taking it apart and I'll tell you the story of this thing. So the story of this amp goes all the way back to 2013-14 or something. My buddy picked this up on Craigslist for free. The story is that it was in a lightning storm, basically, or, you know, somebody's house's electrical got struck by lightning, and after that storm, it never worked again. I don't quite remember if it was blowing fuses or not, but it was definitely not working, and we couldn't figure out why. So that was kind of before I had taken the deeper dive into this stuff. And he gave it to me for free and said, here you go, maybe you can fix this someday, I don't know. And I said, okay, sounds good to me. So I took it in, turned it on, you know, nothing's happening, no sound out of the power amp, and we're not getting a relay click either. I spent a lot of time trying to figure this dang thing out, and I could not, for the life of me, figure out what the heck was going on with this thing. So what ended up happening is, you know, I'm working with my other buddy over Google Chat, and he's trying to help me figure it out. He can't quite figure it out either. And then one day, my friend who bought this, I was just texting him. I sent him a picture of the inside, and I was like, I don't know what's going on. Like, this is where the power amp is. And he says, you know, those resistors right there look kind of weird. And I thought, huh, yeah, you're right. And then I poked those resistors, and they disintegrated. We're going to see those resistors in a minute here, and I'm going to be able to point to them for you, because I used a scrap resistor off of some random board I had. So maybe now I have the right resistor and we can properly replace it. But yeah, after that I got it working, and then I restored it. You can see, well, you'll see eventually if you can't already. I replaced every single capacitor in here. It looks like I left the transistors in the preamplifier alone, which is okay. But one big mistake I made with this thing is that you can see there's like some little pins here that you can unplug. I switched the right and left preamp out, or I did something to where this balance knob works in reverse of what it's supposed to, and it didn't used to do that. So that's another goal I have in this, is I'm going to figure out how to get that to work right again, because that's kind of a big oopsie. And it might be these two wires here, I don't know. This thing is constructed very interestingly also, so let's go inside. You know, this is a late 70s amplifier. I think we're at about 50 something watts per channel in here. Don't remember the exact number. And you can see we've got our selector and tape monitor switches right here. This might be part of the power supply, I don't even remember, but like basically we're getting to the point where we've got different circuits on different boards. Like I'm pretty sure that's phono preamp. This is preamp right here. And then look at how the volume and balance control is on like this little slant right here. Very goofy. You've got these cool little shafts with grounding PCBs attaching them so you can have a good isolation or whatever. And then under here is where the power amplifier is. You can see my new filter capacitors. They're not exactly the correct replacement, but they are the same value, 6800, and you can't quite tell until you look straight down. You can see there's some exposed PCB right there because they don't sit perfectly on a where they're supposed to be. And then that's a pretty nice sized transformer for an amplifier of this size. So this is a very good piece of equipment. I really like the sound of it. So I'm excited to get it working again. So now let's take off this bottom cover, and that's going to give us some exposure to the power amplifier section, and you'll see the output transistors beyond this right here. Alright, let's come on off. And there she be. We have our output transistors right here, and here is the power amplifier board. And now I see those resistors I replaced. And I also think I see the problem. What if it's that easy? So there's a small chance I might have just hooked something up just wrong and caused these fuses right here to blow. Let's see if I can get the light just right. Yeah, I think you can see those two fuses are blown. But yeah, it's this resistor right here that was fried, and then over here, this is the same resistor for the other channel. You've got your bridge rectifier diodes on the same board as the power amplifier board, and then on the other side, you have more power supply stuff, I think. Then here's the outputs. Like I said, you've got original Hitachi outputs on all four. And then these NEC guys, I think they might be temperature sensing. Or driver transistors, actually. That would make more sense, because I don't see any driver transistors on this board here. Yep, I replaced the relay, I replaced all these green capacitors, these purple ones too. So yeah, I'm optimistic that if I replace these fuses, everything will start working again. The only issue is I don't think I have fuses that size, so lucky me, I get to order some. And while we're waiting, I found my error with the balance knob, and it was these two right here. See, I had them switched, and I will show you why I had them switched. This is the preamplifier out. I'm going to switch to the photo I took when I was working on this back in 2015. You can see it may look like the yellow is supposed to come first and the red is closest to the outside, but in fact it is the opposite when you look closely at the clear part of the wire. So, silly me, didn't look closely enough. It appears I did the right thing in the moment, but I did not. So, glad I finally figured that out after all these years. Alrighty. Who wants to guess how much these two fuses cost at Home Depot? $9. $4.50 each. But, you know, Mauser is $8 shipping. And even though they sell them for 30 cents a piece, I wanted them now. So, let's hope this doesn't get expensive here, because that'd be a real shame if I had to already replace my very expensive fuses. Okay, those are in. And I think what I can do now is I can flip this on its side, plug my phone back in, and we can see if the things are working again. We will stay on the dim bulb for this, see what's going on. Okay, we've got everyone's favorite song playing. She turns on, and I've got great sound through each side. There's the right, there's the left, and it's very nice to have this balance not working properly again. Alright, that's it. It was that easy. So yeah, sometimes you get lucky with repairs like this. I really don't think there's anything else to talk about in this video. You saw my restoration work, my recapping. I'm happy to look inside and see that it's all holding up pretty well and there's not really anything else wrong with this thing. I think at the end of the day what happened is maybe I was moving around the speaker wire and I might have shorted it together when there was a signal going through, and it might have popped that fuse. And that's just one more thing that's really great about Sansui. Like, if you work on this stuff, you'll generally see that there's a lot of redundancies, a lot of really good stuff that they do to make their receivers like really reliable, honestly. Because, like, you know, if that fuse wasn't there, it might have taken out a semiconductor. I would have had to go searching for that, and I might not be able to find an equivalent replacement, because, you know, 50 years later, you can't get all these parts anymore. But This mid-70s stuff is pretty okay. You can generally get stuff. It's not until you get into the very early solid state and then in the later solid state with the integrated circuits that you get into difficulty finding replacement parts. Kind of like this right here. Yes, this is going to be part of a future video. This is a STK50 from eBay. Is it real? Who knows? We're about to find out, so stay tuned for that one. So yeah, thank you so much for watching. Be sure to subscribe if you like seeing stuff like this, because there's plenty more coming. I'll see you in the next one.